Hey guys, Jeremy KJ7IAZ, and we're here for another antenna build. This time it's going to be a vertical stacked dipole array. Hang out and we'll show you why you should build one of these for yourself. So I'm Jeremy KJ7IAZ, and today we're going to build an antenna for VHF and UHF. It's going to be a stacked dipole. We're going to use two dipoles, one on top of the other, and I'm going to show you guys some drawings and some stuff off of antenna modeling to show you kind of why we do that. This is a great way to get a little extra reach on something. The way I'm going to use it is I'm going to put it on my WinLink station to get it up a little bit, my antenna a little higher, and it's going to have some more omnidirectional gain. And if we look at some of this stuff here, you'll see why.
So this is just the vertical dipole, one dipole. You'll see there's kind of a big bubbly shape around there. And then you'll see when we add the second one in the stacked arrangement how it drops it down and compacts it. It really compacts it, and it gives you a bunch of dBi, dBd low on where you want it. That's why we're doing it.
Now, you could be using this for something like I'm using it. You could be using it if you need a little extra reach to get to a repeater on your, little handy talk or whatnot. We did do another one where we did a Yagi that helps with that. If you have one antenna or one repeater that you need to get to, a Yagi is a great way to do that because you can point it right to where you're trying to get to, get in and out of the repeater, and it works great. If you have a bunch in an area and they're all around you, an omnidirectional antenna might be a better choice. You get that little bit of gain in every direction, not just one. So depending on what you're doing and what your use case scenario is, you might build one or the other or something completely different. But all right, well, I'll show you some of the stuff we're going to use. I got a couple pieces of coax here. This is RG6. This is 75 ohm. This is something that they would use for TV. We can use this and get away with it because your dipole is roughly 75 ohms when it's straight across. So you don't lose anything on this. You need two equal lengths. The length doesn't matter as long as they're the same. Okay, so make sure these are the same exact length. So you're going to go one end into each dipole, and then the other ends are going to combine into a feed point. So we've got a little SO239 panel mount here. We're going to end up putting these together and mounting it on this. You're also going to need a piece of PVC pipe. I've got two pieces here. One's 4 foot and one's 6 foot. You can use just a straight 10-foot piece, but I kind of like to split it up because it makes it a little bit more portable. You can take it apart. It fits in the vehicle a little bit better. And so we'll work with that too. So, and then of course I have a coupler because I need the coupler. Put these together, and then I got a couple end caps. So I got one I just left alone. We'll put this will be on the top, keep all the rain and the bugs and stuff out of there. And then I got one I drilled a hole in the bottom of it already for you, and then that will run, the coax will run out of this. We'll make our connection to this, and then we'll have a little bit of a pigtail there or whatnot to make this accessible easily when it's up there. And the other thing you're going to need is some of this copper tape. Okay, this is just one way to do it. I've cut these all the same. This is 1 inch. I think you get a roll of this stuff for, I don't know, $5 or $6. It might be a little bit more now, but I've had this for a while. I've made several antennas and kind of experiments and stuff with it. It works really good. I got a fun video. I made a mustache antenna, so you go check that one out too. After the end of this, you can kind of see how that stuff works there. But you know, a little bit flimsy stuff, but once it's attached to something, we're going to attach these onto here. So you'll see how that works, and it should work out really good. Couple, different size drill bits, wire cutters, that kind of stuff that you're going to need. And then we got to have some black tape because I like to use copious amounts of black tape to make sure everything's kind of waterproof that way. So, well, let's get to it. Okay, first of all, I'm going to take my short piece. I'm going to build out one of the dipoles on this. Make sure this is nice and clean, and then the best way to use this stuff is to get one piece started. So on this here, I've made these are all the same length. Okay, you want to have them all the same. I'm at 18 inches. Okay, when we get done and seeing this, we'll just make sure. You could start at 19 if you wanted to hit a little bit lower on the band, but it's going to have some pretty good bandwidth when it's all said and done, so it should be fine. Either way you want to do it, 18, 19 inches. But I'm using 18 inches right on the nose, so you guys can copy that if you need to once you see where this is at. So I just like to start a little bit off on the edge of this, okay? And then I'm going to put this up. I'm going to have enough room for a cap on the top. We'll put that on there so we don't mess that up. And then we're going to just get this kind of lined up where it's going to be, and we'll just hold this down right there. And this is all adhesive, so it just sticks. And then I just peel this off and run my finger down with it. It's a little bit tedious. I'm getting a little crooked there. If I go this way. A little bit of tension's good. Too much, you'll start breaking stuff. So you can kind of come back and get the rest of this tape down. This isn't the smoothest one, but maybe they'll get better. A little bit crooked, but you get the point. This stuff is pretty inexpensive, so if we wanted to, we could tear it off and do it again. And then we'll do the second piece. Same concept. And we're going to leave about, I don't know, an inch. I don't really measure that. I'm sure it has a measurable difference, but like I say in all my antenna videos, it doesn't have to be perfect to work. Antenna building is an exact science that just has to be close to work. So what we're going to do is get this little bit started. We're going to give it an inch. Basically all I'm going to do in between here, I'm going to drill a hole for my coax to go in, and then I'll take my coax out the bottom. It'll meet up at the bottom. But I just need room for a hole, and then I'll take the center conductor to the top and the shield to the bottom, and then we'll solder those on there. You can actually solder on this stuff, so it's kind of cool. But we'll get this one going here. If you kind of hold it this way, peel it, and then stick it. You could do this same theory with a piece of wire, same measurements. This is just going to be slick. So we basically have the makings of our first dipole. We just need to drill out a hole. So I like to start with a little piece here. We're going to go right in the middle. Little smaller drill bit. And then we'll switch that out to a little bit bigger one. Nice thing about working with PVC is it's easy to work with. So we're going to take, so I used 10-foot sections of this. I figured I got, 18 inches, so I should end up with 1.5 feet at the end. We'll have to double back the bottom one a little bit, but that's okay. Now this is the tricky part, is trying to get this in here. So if you put a little bit of a bend on this, just get it started. And then once you start stuffing that, so it gets going, it's a little bit easier, but I might actually drill that out a little bit more that way. So what I did is I put a little angle in here and then fed that through. It worked a little bit better. But now we're going to take our center conductor and solder it to the top and our shield to the bottom. All right, so that's what that looks like. I'll try to do a picture too so it's a little bit focused. But And then we just basically got to prep it to solder. Well, I like to just put a little pad of solder on each end, and then I can kind of push that in there and heat it up, and it just kind of sticks together. I'll try to get that as best I can for you. I don't know how well this will show up. I'll try to zoom it in on the thing, but so I got one over here, and it doesn't take much. I just get a little bit of solder on the deal, just tin it a little bit, and just kind of just tap it. It doesn't take long. The foil is thin, remember, so I just use good heat, and then I just get kind of a pad built up there. So then I can tin each one of these. Go to the edge on this a little bit more here, and then these will get tinned, and then it makes for a really easy solder as soon as it goes. Shield's always a little tougher because it's like a big braid. Let's try to get that to take a little better. Okay. So now, trying to do this without burning the heck out of myself. It's kind of nice to have some pliers or something. So we're going to bend this down a little so it sits in there nice. We'll take our pliers, bend that over. Nice. Okay, so we get that in there. This around. Put a little bit of heat to this. Solder on there. That should hold nicely. Might try to get a little bit more heat to it here. There it went and it dripped down. That was better for sure. And on this side, we'll kind of do the same thing. Here's a little bit better view of it here. We'll get in there. You got a little solder blobs there, and it's attached. So it's all okay. So we set that one aside, and for our second section, to get these things to be about 18 inches, it's a quarter wavelength apart. If you remember from our diagram, we got that big bubble, and then we kind of squished it down, and you can make that different lengths that you know, from a quarter wave to a half wave difference, and it's going to make that shape a little bit different. Really, for all general purposes, if you do a quarter wavelength, you should be good to go. You can go up to a half wavelength. Quarter wavelength keeps it a little bit closer together. Makes it a little easier to build physically. But yeah, either way, it could work. So we're going to put this on the second one. But to do that, we need to measure down 6 inches from this one, just the way I had that other one cut. It's going to be 18 inches from the tip of the bottom tip of the top one, if that makes sense. So we'll go 18, but on this it just needs to be 6 inches, and then we'll be good to go there. So that'll be about right here. So that'll be the top of our next one, and so we'll start putting those on. We'll just have a little room here for that coax connection. Okay, so we just need a hole here and run some coax. And then that's what I do is I like to it'll just put a little angle on it. Get that to feed right. Some of them burrs out of there. You can use a little knife. Didn't really show you that on the other one, but yep, just a little knife to kind of keep that from being too sharp. And we'll get another piece of coax strung through here. And out the bottom. That little bit of angle makes all the difference for doing this. So then the other piece will go through this whole tube when we put it together. Leave a little bit there and strip this. Show you a little bit more on this one here, how I was doing this. Could use a coax stripper, but we'll just do this. Call it the old-fashioned way. Take all of this stuff down. I just give it a little twist. Makes a little pigtail there. And then we'll do the top bit here. This stuff cuts a little easier. And then you can kind of just pop it off. And then that'll fold over. Get that stuff down in there how we want it. Make sure that's not connecting. There we go, that'll be good. We can get those two bits soldered right there. Okay, I'll show you this here. So what I did, I got that soldered down just like the first one, and then I just wrapped it in some black electrical tape. Keeps the weather and stuff off of it, and then it's all kind of protects it a little bit too. So we'll do that, and then we're gonna get them together, and we'll get the other feed line stuffed through, and then we'll make our end next. So I'll show you that process. All right, so I got the coupler on this end here. We're basically just going to take this and just stuff it in. This is like you would expect. So we're going to feed this through. Don't forget your coupler if you're doing it cut in half. If you're just doing it one solid piece, you don't need the coupler, but we'll just couple that together like that. We're going to make sure our dipoles are lined up. Give a good push on them and move this off to the side a little bit. Turn this around. Should be able to set that there like that to work. Okay, so basically this is where our feed point will be. We'll have a little bit of a pigtail there. We got our other piece that's got a hole in it. We're going to start this off going through the longer piece. Actually, I think I want to do that different. I think I want to try to get this stuffed back up in there first. So what we're going to do is we're going to take this and okay, I actually kind of shifted gears. I'm just going to line these two up here and fold it over here. We'll put the we just won't do it with a cap. I think we can get it to fit. It's just so tight that I don't really want to. So if you're hoping to build something like this, maybe get the bigger pipe. I think the next one I do, I think I'm going to get the 1-inch pipe. Just everything will fit a little bit better. So I'm just folding this around. I'm going to just put a couple different places where I put some tape just to hold it together. You're just trying to get it out of the way. And then your ends can be closer to the same. And it'll make easier for making that pigtail at the end. So let's do this. Doesn't have to be perfect, but I think definitely doing the 1-inch pipe, that'll slide right in there way easier. You get a little bit more added cost, but you're talking a couple bucks, and I think it's worth having it. Plus, it'll be a little bit stiffer. So use a 1-inch pipe if you care to. Other than that, we basically just have to build this down. And we're going to strip both of these back. We're just going to put it onto this end. Okay, I didn't realize my battery died on my camera, but here, I'll try to show you this here a little better. So this is kind of what I ended up with. So the center conductor, you go into the middle of those, and then the shield, you just go to the outside. So when you put your connector on there, you're going in there. So a dipole typically has a feed point impedance of around 73 ohms when it's in this configuration, depending on the height on the ground and the stuff around it and whatnot. There's a lot of variables and stuff going in there. When you run them two in parallel like this, it should act like a resistor, and it should be around 36, 37 at the feed point here, which isn't 50. It's not ideal, but it should get us a 1.5 SWR or better, and should work pretty good this way. So let's get it up somewhere where we can test it out, and we'll see how it works. Okay, so I'm out here testing. It's starting to get a little rainy, but you can't really see this. So I'll kind of describe what I'm doing here. So I just got this hooked up to the Nano VNA and leaned up against my mast here just to try to get it away from any of the other metallic stuff. And it resonates about 149, and it's like 1.2 SWR, so a little better than we expected. And as I lift it up and raise it up and try to stay away from it, that resonant point goes down. So it gets down to around about 147 and a half. So full disclosure, I did add an inch of foil on each end to try to fix it to start with. It didn't seem to make a big difference, but it did move it a little bit. I'm hopeful that when I get it up on the roof and away from everything else, it'll come in about right where I expect it to. Getting it up off the ground and stuff a little bit too. So that's enough for today. The thing works. I'll probably do a part 2 when I have it up and on my WindLink station, and I'll get it measured and stuff there too, and we'll see a little bit there too. So make sure you like and subscribe so you can see part 2. But yeah, you should be able to hook it up however you want, and get your handy talk hooked up to it, and you should have quite a bit of gain and be able to utilize that. The only other thing I might do is, before I put it up there, is I'll take some black tape around all the copper, and I'll black tape all the way up where there's copper, just to kind of keep it safer from, if something bumps into it or whatever, it doesn't scratch it and tear it. So it's a little sensitive, but it works good for this kind of stuff. So this is a $20 antenna, less than $20 probably if you have stuff laying around. This is KJ7IAZ wishing you 73s and happy building.